Okay, so law of cosines 3.2. I found this image right here. And again, we're not memorizing the formula. It would be nice to have it memorized. But they did kind of break it into two pieces for you now. We have seen these before. We have seen these where they solved it for the side. So you've got these sides that are all here on the sides here, a squared, b squared, and c squared. They've also changed it so that they've solved it for the angle as well. So they took all of this stuff here and they moved it to this side of the equation. And they got the angles by themselves, which is actually really helpful because if you're looking for an angle, you'll go straight to this formula. If you're looking for a side, you just go straight to that formula and find the one that you're missing. The key is to know when you have to use law of cosines, and it has to be when you've got those two different options. You got three sides, you got to use law of cosines because you can't make one complete fraction for law of sines. Or you could use, if you have SAS, you also have to use law of cosines. So those are the two where you've got to use law of cosines. So let's look at the first two examples. They're going to have one with SSS. That's this one right here. And then you're going to have one with SAS. That's example 2. So this one, in example 1, they've given us all three sides. So I'm going to need an angle. And if I want to go alphabetically, I would find angle A first. So what I'm going to put down is cosine -1 of A. I have to put the -1 because I want an angle. And I'm going to be using this formula right here, even though they didn't put the -1. You could actually write that in there. They are actually -1s. You're going to have to find an angle with this formula. So cosine -1 equals, and then if you look at the formula, it's b squared plus c squared. So it's the other two letters, not the a, because you're using angle A. So it's the other two. So it's going to be 19 squared plus 14 squared minus the a squared, which is 8 squared, all over 2 times 19 times 14. Just a nice quick formula, and you just put it right into your calculator. I would actually do the top first and then the bottom and then divide them, just to be on the safe side. And what's cool about your calculator is this has an x squared button. So you can just put 19 squared and then don't figure it, just put plus after that, put 14 squared, and then put minus, and then put 8 squared, and it does the whole thing for you. You get 493. And then you get 2 times 19 times 14. Bottom is 532, and the bottom better be larger. It's a cosine. Cosine is A over H. H is always your biggest side. You better have a bigger number on the bottom so that you can get a decimal that has less than 1. You need to be less than 1. So 493 divided by 532, you get 0.9267. So inverse cosine of A is 0.9267. That's the decimal that you're going to plug into the inverse cosine. So second function, cosine, not sine. We were doing law of sines before. This one's cosine. And then you do a 0.9267. I would practice these on the calculator because I've seen students have everything right there but not plug it in correctly. And that would cost you to miss the whole problem. So your number here is 22.1. That's your angle A. 22.1 degrees. Should be your smallest angle because A is our smallest side. Once you've done law of cosines once, you don't ever have to do it again in that problem because now you've got two A's. So now I can take my sine of that 22.1 and put it over little a, which is 8, and now find the inverse sine of angle B. So I want to go to B next. And side B, I think, is your 19. Yes, side B is 19. So we're going to put that over 19. And just do your cross multiplying. So sine 22.1 times the diagonal of 19, and then divide that by 8. And you're going to need to get a 0 point something because you want an angle. 0.8935 equals your inverse sine for angle B. So plug this decimal into your inverse sine this time. Be careful, you will go back to sine now. Now we're in law of sines again. So law of sine, inverse sine, 0.8935. you should get a 63.3 degree angle. And then the nice thing is your last angle is just a subtraction. 180 minus the 63.3 that we just found, minus the 22.1 that we found earlier. So let's see what that is. 180 minus 63.3 minus 22.1, 94.6 is angle C. Okay, so that's solving the whole triangle. That's if you've got all three sides. Law of cosine formula is nice. The second grouping there where you're looking for an angle, that'll get you the angle quickly. Then use law of sines to get the other angle, then just subtract it from 180 to get the last angle. So if you ever have a problem where you got all three sides, this is a good example to look at. If you get a problem that has side angle side, okay, we are going to need to find little a first in this one because you have angle A. So we're going to need to use the other side of that formula, and it's going to be a squared equals b squared would be 15 squared plus c squared would be 10 squared minus 2 times 15 times 10 times the cosine of 115. Again, what's cool about these calculators is you can put this whole thing straight in your calculator and it will give you one answer. You can put it straight in. You got 15, hit the x squared button, plus 10, hit the x squared button, minus 2 times 15 times 10 times cosine of 115. You're going to get a number that is 451.79. So a squared is 451.79. You will square root both sides. So just square root that, square root of 451.79. And you get 21.3 when you round it off. So that's little a. Now you have angle A and little a. Now you have enough to do law of sines. So sine of 115 over 21.3. We want to find angle B next. So inverse sine for B over little b, which is 15. So we're going to multiply the sine of 115 times the diagonal of 15. I'm going to divide that by 21.3. Need to get a 0 point something, which we do. 0.6382 equals the inverse sine for B. So this decimal needs to go into your inverse sine. So let's see, inverse sine. We want to do second function sine, 0.6382. That'll get you your angle B of 39.7 degrees. So you've got two angles. Now you want to find your third angle. So angle C is 180 minus angle A, which is 115, minus angle B, which is 39.7. So 180 minus 115 minus 39.7, 25.3 degrees. So you found all the pieces. All the pieces that were missing. That's what solving the triangle is. All right, so that was the first two examples. Now the rest of them, we don't have to solve the whole triangle. That's kind of nice. All we have to do on the rest of them is find the piece that's missing. Okay, so there's going to be a lot of practice coming up about these application problems. You want to be able to apply your law of cosines and your law of sines. So here's an application problem, a women's softball field. Okay, if you drew a line from pitcher's mound to first base, it would make a triangle with the first base line. And the pitcher's mound, from pitcher's mound to home plate is 43 feet. That would be for softball. In a men's baseball, the professional baseball is 60.6 feet. So in the women's softball, it's comparative to it is 43 feet. And what we know is the bases in women's softball are all 60 feet apart. So you've got two sides of your triangle, plus you've got this 45-degree angle right here. So you actually have SAS in the triangle. So we're going to look for h. That's all we need. And h squared is going to be the 43 squared, which is like your a squared, plus your b squared, which is 60 squared, minus 2 times 43 times 60 times the cosine of 45 degrees. And what's nice about it is that's all going to go straight in your calculator. 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45. Put it all straight in, you get 1800.3. 1800.3, and you square root both sides. So square root 1800.3, get 42.43. That is really, really close to being an isosceles triangle. Because from pitcher's mound to home plate is 43, from pitcher's mound to first base is 42.43. So it's like 0.6 feet away from being a perfect isosceles triangle. So close, but not quite. So that's 3. That was the only piece they wanted. They just wanted to know how far it was from pitcher's mound to first base, so you didn't have to solve anything else. There's always a ship problem or something with directions and navigation where you got to figure out like a bearing or whatever. Ship travels due east, and it's traveling due east. It's going 60 miles due east. Okay, so it's going due east 60 miles. And then, so ship travels due east 60 miles, then adjusts its course northward as shown. So it's going 60 miles right here. Whoops, that's not what I want. Yeah, it's red here. So 60 miles due east. Then it's changing a little bit of course to go a little bit towards the north, not straight north, not due north. And it says that after they've gone 80 miles, they're 139 miles away from their port of departure, where they started. So in other words, they have gone 60, they've gone 80, and then their GPS is now telling them that they're exactly 139 miles away from home. Okay, so that's that third side. So you actually have all 3 S's. What they want to know is what is the bearing from point B to C? So if you made a north-south line right here, what is this bearing is what they're asking for. I'll put an X in there because that's what they're asking you to find. What is that bearing? Okay, so we are going to need to find the entire angle B. From here to here, we need this angle. Okay, so that means we have to use law of cosines to get that angle because we've got all 3 S's. So I need to use the 139 to match up with angle B, right? That's going to be where B is. And I think that the formula we want to use is where we're looking for angle B. So if you remember this little chart I gave you, we're looking for angle B. We're going to use this formula right here. So this one. That's the one we're going to use. A squared plus C squared minus B squared over 2AC. Okay, so let's check that out for this. We're going to look for angle B. So inverse cosine of B. Okay, so cosine -1 for angle B. And you have the other 2 side squared. So 60 squared plus 80 squared minus the 139 squared, all over 2 times 60 times 80. Now I would get each side. So I would do 60 squared plus 80 squared minus 139 squared. You get negative 9,321. And I'm really happy we got negative, because that means that, and if you look at this, it's kind of like you have kind of like an XY axis right here. And we know our angle is going to be an obtuse angle, which is going to put it in the second quadrant. And in the second quadrant, cosine is a negative value. To get to the second quadrant, you need to do a negative x and a positive y. So your x is your cosine value on the unit circle. So cosine is a negative value in this second quadrant. Remember, cosine negative, sine's positive, and tangent's negative because they're different. So I'm glad we got a negative number on there because that means that you're going to get an obtuse angle when you plug it in. And we know angle B is obtuse. You can see how big it is. It's almost 180. It's so big. Okay, let's do 2 times 60 times 80. You get 9,600. Go back to blue again. So 9,600. So that means that the inverse cosine of B is going to be, divide those two, you're going to get negative 0.9709. And if this was not a negative number, you would not be getting an obtuse angle. So I'm glad it's negative. So inverse cosine, negative 0.9709. But in that negative, you're going to gives you 166.1 degrees. I told you, it's almost 180. It's a really big angle. And if that wasn't a negative number, you would have gotten a really small answer. And that's not what you wanted. You want the big angle. So what we just found was that the whole angle from here, okay, all the way over here is to this dotted line right here, actually. To this dotted line. That is 166.1 degrees. That's not what my x is, though. I want the bearing. I want to know from north, how many degrees am I going towards the east? So I need to subtract out this right angle, that 90, to see what's left over for my x. So I'm going to take my answer of 166.1, and I'm going to subtract 90 degrees from it. And let's see what we get. 166.1 minus 90, you get 76.1. That's going to be your bearing. That's what's missing. From the north, you're going 76.1 degrees towards your east. Okay, that's the x. So I'll put x equals in front of that so you know that's what I was solving for. Okay, that's going to be the angle. That's the bearing. The whole thing was 166, but we took out the 90 to see what was left over from north. We wanted the north amount, not the whole angle, just the north part. All right, the last part of today's is one last area formula. I've given you a bunch of them, and I listed them all right there for you. Area of a triangle, there's actually 4 formulas. One of them we don't ever use. You could use it. This one right here, it's for area of an equilateral triangle. But there's so many ways to find the area of an equilateral triangle that I didn't give you this formula, because you could use any of the other formulas to solve for it. So I didn't give it to you, but it's there. I'll put it up there for you. If you have all 3 sides, if you know all 3 sides are the same, you can just plug it into that little formula and you'll get the area of an equilateral triangle. But we know the base times height times a half. We know this first formula right here. Okay, that one we use a lot. That's just for regular triangles, or even right triangles. You get a base and a height for the 2 legs. This is the one that we've been giving to you lately. If you've got 2 sides and an included angle, you can just plug it into that formula. And then today we've got what we call Huron's formula. Now Huron is Alexander Huron, I guess is his name. That's actually called Huron of Alexandria. That's what his name is. He was a Greek geometer and inventor, and he specialized in finding areas and surface areas of regular polygons. So he came up with this new formula. So if you got all 3 sides, for you to use any of these formulas, like especially this last one right here, you would have had to use log cosines to find the included angle. You would have had to do a log cosine first. And then you would have plugged it into this formula. Well, he's thinking that, well, I can just go straight from my 3 sides, find S, which he gave us a little formula for that. and then plug that into the square root, and you can get your area straight from that formula. So let's just apply it to these three numbers over here. First thing you'd want to do is you'd want to find your S value. Now your S value is the sum of the three numbers together and divided by 2. So if you add those all together, you get 168 divided by 2. So your S value is 84. Then your next step to find your area is to write a huge square root and start with S, 84. And then you want to do 84 minus the first side, 43. And then you want to do 84 minus the second side of 53. And then you want to do times 84 minus the third side of 72. Okay, so there is just plugging it in. So you're actually going to have, when you solve it here, you're going to get 84 times, let's see, that would be 41 when you subtract those, 51 when you subtract the second ones, and 12 when you subtract the third ones. So you're going to get a very large number inside of there to square root. It's 84 times 41 times 51 times 12. So it's 84 times 41 times 51 times 12. Oh, not 51. Sorry, there's a mistake. It's 31. I don't know where I got 51 from. My head was saying 31 and my pen wrote 51. I'm going to blame it on the pen. Okay, so let's type those in now. 84 times 41 times 31 times 12. So that's better. You have 1,281,168. And you're going to take the square root of that. So your square root of that is 1131.89. And that's in square meters. So area is always measured in square meters. So again, now you just have an extra formula for area in your arsenal that you could use at any time. You just have all three sides and you want to get the area, now you have a formula for that too. So that's just an extra one for you. All right, that's 3.2. All of it completed.